Hello, in this short video we shall see what is the typical expected API response times and how to enhance the performance of an API. Let's get started. For real-time applications, which are like gaming applications, video streaming, or financial transactions, low latency is critical. So the response times expected are like 100 milliseconds or under. Interactive web applications are applications like social media platform, e-commerce sites. They generally aim at a response time between 100 to 300 milliseconds. Business applications, including enterprise systems and internal tools, often target responses between 300 milliseconds to 1 second. This range of performance is acceptable for applications where real-time performance is not critical. Batch processing or background tasks or non-interactive operations, response times might be more flexible. In such cases, response time can extend to a few seconds without impacting the user experience. Please do note that many organizations define SLAs, which are service level agreements that specify the acceptable response time for their APIs. SLAs may be based on criticality of service and the impact of response time on the end users. Now that we have seen the expected response time, what are the typical ways in which the API performance can be enhanced? So we can optimize the database queries. Database is one of the very prime reasons for API degradation of performance. If we are using unnecessary joins, if we don't have indexes in the database, and if we are fetching unnecessary data, all these reasons would lead to slow API response time. Caching. This is also related to data from the database. Instead of fetching the data all the time, we can implement caching for frequently requested non-changing data. We can use tools like Redis or Memcached, which are in-memory database caching tools. Compressing API responses is a common practice to reduce the amount of data transferred over the network. This leads to improved performance and reduced latency. The compression and the CDN fall into the bucket where we are trying to reduce the network latency. So wherein by compressing we are reducing the amount of data, thereby less data meaning it will travel faster, and CDN is a network of geographically distributed servers designed to improve the performance, reliability, and efficiency of delivering web content to the users. CDNs work by caching and delivering content from edge servers located closer to the end users, reducing latency and offloading traffic from the origin server. So these also enhance the API performance to a great level because the data is not being fetched from the server. This is like from a cached CDN server, the data is being given to the end user. Load balancers, when we are able to scale our application services which are responsible for fetching the data, applying business logic, and returning the data back to the user. So that's where if we can load balance, we can have a scale factor which is proportional to the amount of scale we are expecting, amount of API calls we are expecting. Then we would be able to enhance our API speeds. A load balancer is a crucial component in distributed computing and networking that distributes incoming traffic across multiple servers or resources to ensure efficient utilization, high availability, and improved performance. Next one is the optimize code. So we can optimize the code and we can review the code and see if there are unnecessary code which is there and if there is any possibility of optimizing the code and thereby reducing the CPU cycles on executing the code. Parallel processing, meaning that if in case, for example, if in case we have to fetch the data from two distinct sources and then we have to apply some algorithm on that and then we have to return the data back to the API as a response, then cannot we implement a parallel processing wherein these two processes are parallelly going, and then we are able to leverage multi-threading and we are able to enhance the processing time. That is the meaning of parallel processing. Reducing payload size. So if we implement pagination or partial responses, we would not be sending the entire data at one time. So thereby we would be able to enhance the API performance. Connection pooling is a technique used in software applications to efficiently manage and reuse database connections. So these connections are typically very heavy. To establish the connection takes time. A database connection takes time, and thereby if we are able to pool the connections and reuse the connections, we are definitely going to enhance the application speed. This helps improve the performance of database driven applications by reducing the overhead associated with opening and closing database connections for each transaction. Instead of opening a new database connection every time an application needs to interact with the database, connection pooling allows for the reuse of existing connections from the pool. Then the last one is not for enhancing but for the continuous monitoring and profiling, so that we are able to understand what is our current performance of the APIs. So we can have tools for continuous monitoring and profiling of API performance. Thank you.